Well, hello, calculus students and seekers of general truths. In this video, I will review some of these graphing methods. We have a bunch of functions here that we're going to graph. And of course, you could put this into a calculator. Of course, you could put it into your favorite software program and see the graph for yourself. But I want to review and brush up with you here on the skill of how to graph this without a calculator for two reasons. First, the simpler reason if you ever have to take an assessment or an exam without a calculator. And more importantly, the greater reason is for you to really understand the behaviors of these graphs, to be able to do it quickly and intuitively, and to really develop your understanding of range, domain, and the analysis of a graph without simply relying on a device to graph it for you and to look at it. So some visual reasoning and logic that we really need to work on here with these problems listed as our help. So for all of these, always begin with the parent function. There are something like 12 parent functions that you really should memorize, although hopefully if you've been diligent with your mathematical studies up to this point, you know them already. They're sort of seared into your mind. So here I have the square root function. So the original function is going to look like this. It's sometimes referred to as the shooting star. That's what square root of x looks like. And then I apply my transformations. I have this negative x here, so that means it is reflected over the y-axis. Right? Or another way of saying that, it's a horizontal reflection. And then I have this 5, which is really shifting it 5 units to the left. And so another way we can think of this function, this is really the square root of negative x plus 5, right? Just rearranging that. So reflecting over the y-axis and shifting it 5 left. Okay. Now, remember that when we're talking about both of these here are horizontal transformations, reflecting horizontally and shifting left and right is horizontal. And so the order of this really does matter. And when we're dealing with horizontal transformations, the shifts happen before the reflections. So we have to take this original graph, imagine what it looks like if it was shifted 5 to the left, and then reflect that over the y-axis. So if I take the original and I shift it 5 to the left, then it's going to look like this. It's still the quote-unquote shooting star function. So this is like the square root of x plus 5, and then we're going to flip it over the y-axis, and then I'll use that to give you my final graph here. This is the xy coordinate plane. So 5 is going to be right here. And if I take that blue graph and flip it over, then it's going to look like this. Okay. A couple of sanity checks that we could apply, right? Notice here that this graph has a domain of negative infinity up to 5, which matches the algebraic interpretation. If you put in any number bigger than 5, it's going to be undefined or a non-real answer. If we were to plug 0 into this function, we would get square root of 5. We get some positive numbers. Okay, and so just some quick tests there to help you to check if your work is correct. If you have technology, you can certainly put it in there and test it. But make your minds do the work. Exercise that visual muscle in your brain. To be able to do these transformations, these flips, these shifts, because you want to train your brain to be able to think that way and to do it intuitively. All right? So let's look at another example here, the absolute value of x minus 2, and let's apply the same concept. We're going to look at first our parent function. All right, and remember the absolute value function is sort of like a V shape type of thing. Okay. So this is what the absolute value of x looks like. Now, if we were to have this x minus 2, well, this is a shift of 2 units to the right. Okay, so I guess I can graph it on here directly. This would be where 2 is at. So if I take the red graph and shift it over 2 to the right, then I have the blue graph. That's g of x right here. Okay. And of course, you can test a few things in here, right? If we were to put 2 in for x, we would get 0, which matches the graph. If we were to put a number bigger than 2 or less than 2, we would get a positive answer. So this is sort of like this point here. We call that the vertex. It's where this graph changes direction from having a negative slope to a positive slope. All right, so I'm going to skip around a little bit here. I'm not going to go through all of this. Hopefully you try to understand and you're able to to brush off some of the rust that you have over the summer or over whatever length of time that you haven't been able to do math consistently. So I'm going to jump to this problem here with k of x, where I have x minus 2 over the absolute value of x minus 2. So this is going to be a more interesting case, okay, a different, maybe a different set of skills, a different set of thinking here. Again, we're focusing here on this function k of x equals x minus 2 over the absolute value of x minus 2. So one of the things that I'm going to focus on here, I'm going to start with this with the xy plane. And we're going to focus on where this graph is undefined, right? And that's clearly at x equals 2. So at x equals 2, something unusual happens, all right? So that's really good for you to think about. For a good thing to keep in mind is that when you're graphing something, you're not sure what to do, just find the places where it's undefined, okay? Well, at 2, something weird is going to happen, right? It's going to be a hole or an asymptote or a jump, something of that sort. Now, let's try some numbers. If I put a number bigger than 2, say 3, then I'm going to get positive 1 on the top and positive 1 on the bottom. So positive 1 over positive 1 is just going to be positive 1. Okay. And same thing, if I were to put 4 into this function, I would get 2 in the numerator, 2 in the denominator, and I would still get 1. Okay. And you can quickly see that no matter what you put into this function, as long as it's greater than 2, you're going to get positive 1. Right? Because the numerator is always going to be positive, the denominator is going to be positive, and they're always going to be the same. Like, this is the exact same expression. So my graph, and I'm going to leave a hole right here at 2, is going to look like that when we have any numbers any inputs that are greater than 2. Now let's look at the inputs that are less than 2. Let's say we were to put 1 in as our input. Well, the numerator is going to give us negative 1. The denominator is going to give us positive 1. So overall, we're going to get negative 1 as our answer. Okay. If we were to put 0 in here, the numerator is negative 2, the denominator is positive 2, so we're going to get negative 1 again. Okay? And you can kind of see that, again, if you put in any number less than 2, the numerator will be negative. The denominator, because it has the absolute value symbol, will always be positive, so your end result is going to be a negative answer. You're going to have a negative divided by a positive if you have any inputs less than 2. And they're the exact same numbers, just with different signs. So that tells us that if we put in any numbers less than 2, but not equal to 2, okay, we're going to get negative 1. So it's going to look kind of like this, right? And I would say not kind of, but like exactly like this. It's going to have a hole, 2 holes actually, and a jump. Okay. So again, this is how you could, and this is a good example too of how technology can fail you. If you were to graph this, the graph might not show you these holes right here, but the fact is we know that they have to be there because you cannot possibly put 2 in as your answer. Okay. Now I leave it to you to apply those same concepts and understanding to this next problem here with h of x, the absolute value of x minus 2. So I've just flipped the fraction, right? So think through it, see what might be the same, what might be different. Make your mind do that work. All right, so we're going to end this video right here, and maybe I'll start another one to work through some of the other types of graphing questions. As always, Ask for help if you need it. Keep working hard and have a wonderful day.